Hello everyone. I hope you all are good. So welcome for AIET 5 JEE paper solution for class 12. So in this session, what we will be doing, I have picked some questions, assuming you might have problem in those questions. So we will be going through those questions first. Okay. So the very first question is this. There are identical charges of magnitude 5 coulomb and they are placed at each corner of regular pentagon. The distance of center of regular pentagon from each corner is 2 meter. The magnitude of net electric field at the center. So pentagon means having 5 vertices, right? So let's draw the pentagon first. So this is your pentagon. And what the question is, charge particle are kept at each corner of regular pentagon. And we have to calculate electric field at the center of pentagon such that distance of each vertex from the center is 2 meter, right? So first let's see what will be the direction of electric field because of each charges at the center. Is there any symmetry or something like that? So if there is symmetry, we will first try to have a look over that because that simplifies question always. So let's have a look here. Electric field because of this charge, because each charge is positive here. So electric field will be outward and it is this. Because of this charge will be this. Because of this charge will be this. And because of this charge will be this. One charge I have not yet considered, but if you see electric field because of these 4 charges, what you can see here, I have not drawn the diagram exactly like that, but if you see here, and if you forgive my little bit of drawing mistake, I must say, then you can see clearly here, this electric field and this electric field are equal. They will cancel each other. Similarly, this and this will be equal. It doesn't seem like here in the diagram because I have not drawn it perfectly, but they will also be opposite. Done. And this electric field will also cancel each other. This will also cancel each other. So electric field, because of these four charges will be equal to what? 0. Now there is one charge remaining at the top vertex here, and electric field because of this will be this. So net electric field will be in this direction, and that will be because of this charge. So let's calculate electric field at the center. So it will be because of only this charge, and its value will be kq by r square. Put the values. 9 into 10 to the power 9. Q ka value is how much? 5 coulomb. R is how much? 2. 2 ka square. So this is 4. Now this is 45 by 4 into 10 to the power 9. So this is equal to 1.25 something into 10 to the power 9 Newton per coulomb. So this is your electric field at the center here in this case, right? So the correct answer will be B. Now let's move on to the next question. So the potential at any point is given by V equal to x y ka square minus 4x square. The magnitude of electric field is. Now, what is the relationship between potential and electric field? If you remember, potential gradient we have studied. And according to that, electric field is equal to minus of dy dx I cap. यहाँ पे electric field will be there. Plus electric field dE by dy j cap plus dE by dz k cap. And while we write this equation, we put one important thing in consideration, that is when we are writing dy by dx, E will be in terms of variables. So while differentiating E with respect to x, we will consider y and z as constant and then we will differentiate. Okay. So this is how we go ahead with this question. Okay. So let's do. So here E is equal to, let's put the values now. D, E value will be how much? Sorry, E we are calculating. So here I have written wrong formula actually. This is V, not E, sorry. This is V, not E, because we are already calculating V. So this is V. Done. So when we are differentiating V with respect to X, we will consider Y and Z as constant, right? So let's put the value of V here. And value of V is how much? X, Y square minus 4X cube. We need to differentiate it with respect to X plus D. Again, same value you put here. minus 4x cube, and this we will differentiate with respect to y. Again, x y square minus 4x cube, and this we will differentiate with respect to z. So how we will differentiate it? Just see here. If I am going to differentiate it with respect to x, I will treat y as constant. So this y is constant. So y square dx by dx, it will become minus d, 4 is constant, 4 को बाहर ले लो, dx cube by dx. So this term will reduce to this, right? And its differentiation will be equal to how much? Y square x. Y square x minus 12 x square. ठीक है? This is I cap. Now plus. When we are going to differentiate this term with respect to y, we will consider x as constant. So this whole will become constant. So constant ka differentiation is 0. dxy square by dy will be how much? So x ko constant hai. So this term will reduce to what? It will reduce to x is constant. dy square by dy minus d 4x cube by dy. And this is also constant here. So its differentiation will become 0 and its differentiation will become 2y into x. So this is 2xy j cap. Now come to this third term. Here, when we differentiate with respect to z, we consider x and y as constant. So if we are considering x and y as constant in third case or third term, I must say. So here, this is also constant, this is also constant differentiation is 0. So nothing in the direction of k cap. Electric field is this in and with minus sign here. Okay. Now let's put the values. We have to calculate electric field at 1, 1, 1. Means x is 1, y is 1, z is 1. So if you're going to put x equal to 1 here, it will become 1 minus 12. So that is your minus 11 I cap. 1 minus 12 minus 11 minus minus will become plus. And this is 2xy. So 2. And minus, when it will go inside, it will become minus 2 j cap. So 11 I cap minus 2 j cap. If you're going to calculate its magnitude, this is a vector, you need to add the vector. So how you will add the vector? 11 ka square plus 2 ka square. And how much it will become? 1 to 1 plus 2. Sorry, 4 ka root over. So this is equal to root under 125 Newton per coulomb, that is unit of electric field. So correct answer will be what? D. I hope it is clear. Now, what is the question? The plane faces of two identical plano-convex lenses, each with focal length f, are pressed against each other using an optical glue to form a usual convex lens. So we have two plano-convex lens. This is one plano-convex lens. This is another plano-convex. What we are doing, we are bringing it together such that we are bringing it together and then sticking it, right? And when they will get stuck, what will happen? When they will get stuck together, what will happen? It will become a convex lens. Okay, usual convex lens. So if you're going to bring these two together, what will happen? You just see here. Here I'm going to paste another one. So it will get pasted like this. So this became usual convex lens. Okay. And its focal length is given as f. Done. Now the distance from the optical center at which an object must be placed to obtain the image same as the size of object. So for this lens, it is said that where the object should be kept, so that we are getting image of the same size. And we know that it happens when object is kept at center of curvature. So if we know the focal length of this lens, we can calculate center of curvature. Suppose its focal length is f dash. So center of curvature means at a distance of radius of curvature, and that will be equal to 2f dash. So we will keep object at distance of 2f dash. Let's calculate f dash. How we will do that? So if we see its focal length is f, suppose कर लो its refractive index is mu, its radius of curvature is r, and its radius of curvature is infinity because this is a plane surface. If we use lens maker's formula, 1 by f will be equal to mu minus 1 because 1 refractive index of media in which lens is kept, that is air. This divided by 1 minus r minus 1 by infinity. Okay? So 1 by f is equal to how much? Mu minus 1 by r. So from here I can calculate r. R value is how much? Mu minus 1 by f. Now you see carefully, this is a lens which this radius of curvature is R. This one is also R, and it is made of material of refractive index V. Now let's calculate the focal length of combined lens. So that I have assumed as 1 by f dash, and that is equal to 1 by f1 plus, or we don't need to add it like this also we could have done. Easier method also I will go to. But before that, let's do it in this way also. Okay. So here what will happen? 1 by f dash को आप क्या लिखोगे? That you can write as mu minus 1 by r1. This will become 1 by r1 minus 1 by r2. So r1, if I'm taking incident light as this, r1 will be radius of curvature of this surface. So this surface has a radius of center of curvature somewhere here, or center somewhere here. So R1 will be positive, will have positive sign convention. So right here, I hope these things are clear with you. These things mean sign convention thing. So I will do it fast. 1 by R minus R2 is this, and its radius of curvature will be, or its center will be somewhere here. So if you are going to measure its center or its radius of curvature, then it will get measured in this sense, but incident light I have taken in this sense. So negative. Now this will become how much? Mu minus 1, 2 by r. And r value is how much? Mu minus 1 into f. It is this, right? So mu minus 1 will get cancelled. And what value you are going to get? Done. So 1 by f dash is equal to 2f. So f dash is equal to how much? It is equal to 1 by 2f. Make sure calculation is not wrong. This is 2 by r. So r value I have kept as mu minus 1 into, sorry, this will be mu minus 1 into f. Just see here carefully. R value will be mu minus 1 into f. This is f. Okay. So mu minus 1 into f. This is this. So 1 by f dash is how much? This is 2 by f. So f dash will be equal to how much? F by 2. So this became f by 2. Now if this is f by 2, then radius of curvature for this lens will be how much? 2 into f dash. That is equal to f. So where the object should be kept? At f. So I did all these things. You could have done it very easily. Some of you may have used that. So we know that if thin lenses we are talking about, okay, here it's not written thin lens. That is why I went through it. But this is a case of thin lens actually. So in thin lenses, I have told you, you have to combine two lenses. Then focal length of combination is equal to what? 1 by f1 plus 1 by f2, where f1 is focal length of first, f2 is focal length of second. So 1 by focal length of combination किसके बराबर हो जाएगा? 1 by f plus 1 by f. That is 2 by f. So focal length of combination is f by 2. ठीक है? And it was not written in the question thin lens. That is why I went through that. But again, we can consider that. Okay, because it is said that it is forming usual convex lens, and in usual convex lens, this thickness will be very little, and that is why we can assume this to be a thin lens. And if we are combining two thin lenses, we can calculate focal length like this. Okay, chalo. Now there are two square plates, L into L, and dielectric constant L by 2 into T by 2 into L. Okay. Arranged as shown, find the equivalent capacitance. So we have a capacitor like this. Everywhere there is a air, only except in this portion, right? So because of dielectric in this portion, what is happening here? What is happening? This is making this capacitor a combination of different capacitors. Just you can see here, we can now look at this capacitor like this is one capacitor having air in between. So this capacitor has area A by 2, thickness T, okay? And its capacitance will be equal to, let's call it C1. So C1 will be equal to epsilon naught A by 2 into T, epsilon naught A by D, okay? So epsilon naught A by 2 into T. So C1 is equal to this. Now here also there is a capacitor. This is also a capacitor, and it is filled with air. Its area is A by 2, and its distance between these two plates is T by 2. So let's call it C2. And if I write C2 will be equal to epsilon naught A by 2 divided by T by 2. So this will become epsilon naught A by T. ठीक है? Now this is C3. So this is C3. अब आप C3 का value लिख लो. So if you are going to write C3, it will become equal to epsilon naught A by 2 T by 2 divided by K. Sorry, not divided by K times. Because when we put dielectric in between the plates of capacitor, its capacitance increases by K times. That is why this. So this is equal to K epsilon naught A by T. Okay. Now, if I say epsilon naught A by T as C, if I put epsilon naught A by T as C, then C1 will be equal to how much? It will be equal to C by 2. C2 will be equal to C and C3 will be equal to Kc. Okay. So this is all. Now let's calculate the equivalent capacitance because we have to calculate that. So this is combination of three capacitors. One is this, another is your this, and another is this. Now you just see here C2 and C3 are in what? C2 and C3 are in series. Okay. Why in series? Because देखो C1 का one plate is this, second is this, and C3 का one plate is this, another is this. So potential difference between C1, between C2 is what? V1 minus V2. And between C3 is what? V2 minus V3. Their potential difference is not same. So they are in series, C2 and C3. And combination of two capacitors in series is like what? We combine them in parallel. Okay. So here C equivalent will be how much? C2, C3 divided by C2 plus C3. So this will become equal to C2 into C3. So that will be Kc square C2 plus C3. So that is equal to K plus 1 C. So that is equal to Kc by K plus 1. Now our capacitor reduces to what? इसके बाद हमारा capacitor कुछ ऐसा हो गया. There are two capacitors. One is C1 and another is this C dash equivalent. Okay. These two are in what? These two are in parallel because both share the same plates. This is one plate, this is two plates. So their potential difference will be same. They are in parallel. And in parallel, we add capacitors like series. So here net C equivalent will be C1 plus C dash equivalent. So C1 is C by 2 plus Kc by K plus 1. You just add it. And if you're going to add it, what value you will get? You will just get here C को आप common ले लो. So K plus 1 plus 2K divided by 2K plus 1 into C. So this is equal to 3K plus 1. So 3K plus 1 divided by 2K plus 1 into C. So 3K plus 1 divided by 2K plus 1 into C. C is equal to epsilon naught A by T. So correct answer is what? A. I hope it is clear. Now, there are two resistors and they are joined in parallel whose resultant is 6 by 5. So there are two resistors and they are connected in what? They are combined in parallel. So they are in parallel. Let's call this is R1, this is R2. Okay? And their resultant is how much? 6 by 5 ohm. Done. So 6 by 5 ohm is equal to R1, R2 by R1 plus R2. Now, one of the resistance gets broken and the effective resistance become 2 ohm. Then the resistance of the wire that got broken, sorry, is how much? So one of the resistance is getting broken. Suppose Karlo, this R1 gets broken. So my circuit will become only this R2. And when it is getting broken, effective resistance is 2 ohm. So while value of R2 will become 2 ohm. Then the resistance of wire got broken is how much? So we just need to put the values here. So R2 value is how much? 2 ohm. So 6 by 5 equal to 2R1 divided by R1 plus 2. So this is equal to 6R1 plus 12 equal to 10R1. So 4R1 equal to 12. R1 will be equal to 3. So answer will be what? 3. Done. Chalo. So correct option is D. Now this is. Now what the question is, there is a uniform disc and that is made of dielectric material. Okay. and that is given a charge of 7 millicoulomb. Then there is a uniform disk, and in this region, this much charge is distributed uniformly. Then the disk is rotated. Now it is getting rotated like this, I guess. Means this is the axis of rotation, and around this, your disk is rotating. Visualization is very important in physics. Now, omega value is how much? Omega is 400 RPM. Means with this angular velocity, it is rotating. Whenever you solve the question, you just should convert RPM into radian per second. And how we will do this? 400 rotation per minute. One rotation means 2 pi radian. 1 minute means 60 seconds. So it will become now in radian per second. So 60, 1010 got cancelled. This is 3. So this is 40 pi by 3. Omega value is how much? 40 pi by 3. And magnetic field strength and the region in which disk is kept and is rotating, that region has a magnetic field. And that value is how much? 30 millitesla. So in this region, suppose Karlo, inward magnetic field is there and its value is equal to how much? 30 millitesla. Yani 3 into 10 to the power minus 2 Tesla. Now, if the magnetic field is perpendicular to the axis of rotation, that is, magnetic field is perpendicular to the axis of disk, yani ki, the one I have drawn is not correct, because axis of disk, it is rotating about its geometrical axis, right? So if I'm taking this as an axis, magnetic field can't be in this direction because they have to be perpendicular according to the question. इसलिए magnetic field का direction ये मत लेना. Magnetic field, let's call it this. ठीक है? The one I have drawn previously is not correct. Because in the question it is given that magnetic field is perpendicular to the axis of direction. And previous direction was what? It was parallel to the axis of rotation. Okay? So that is why I have done this. Now, then torque on the disk is, what is the value of radius of disk is given, torque you have to calculate. Torque value is how much? M cross B. Okay? M is equal to how much? A cross B. Just go to the formula first. Now here current is what? That's the question. Current is not given in the question. Instead, what is given? Some amount of charge is uniformly distributed over the flat surface of this. That is given, right? So from there, we need to calculate current. So this is a task. Area. Area is given already. Magnetic field is given. An angle between area vector and magnetic field is what? That will be 90 degree, because magnetic field is where magnetic field is perpendicular to the axis of rotation, and normal to, and axis of rotation is in which direction? Normal to the plane. Area vector also happens to be along the normal to the plane. So angle between area vector and magnetic field is 90 degree. That is, if I write IAB sine theta, then this theta is equal to how much? 90 degree. So this will become IAB. B is known, area is known, I need to calculate. But can I plainly calculate I and write it? Let's see here how we will do that. Okay. So let me make you first understand here what is happening. It is rotating along this axis. Okay. Yani ki this is the axis of rotation. Disk is in this plane. Okay. It is rotating like this. Hope you are understanding. Okay. Like that. Now, you just see here, suppose charge is present along, charge is present or distributed over this flat surface. Then if you take this charge, then this charge is going in a circle of this radius. Okay? This charge is going in a circle of this radius. Done. Again, we have studied in circular motion that if we consider that a disk is going in a circular motion, that is here, because it's rotating like this, so it is going in a circle. In that case, every point will have same angular velocity, but different point will have different linear velocity, because v equal to omega r. Okay? Omega v is going to be different. And if v is going to be different, time period of every point to go around in a circle will be different, because time period is equal to how much? Will it be different? I just want to ask. It may not be. Just say time period will be equal to how much? 2 pi r by v. ठीक है. And if you see here, v by r that is equal to omega. Time period is 2 pi by omega. If omega is constant, time period for each charge to go round and round in circle here will be same. So time period is same. Now current value will be how much? Current value, if you see, that is equal to q by t. That is equal to q by t. So can I do this thing ki can I calculate this q by t, like can I put q equal to 7 millicoulomb and time period equal to 2 pi by omega and calculate I and put it here and get the answer? Is it way? Can we do that? No, we can't do that. But why? That's the question. Now, it is because we know that here torque is equal to m cross v, but this is the mistake we can do. Here torque is equal to m cross v. Though current will be same, like we can calculate current like this. But m is equal to here what? M is equal to I into A, area vector. And if I'm taking this charge is going in this area, Then area enclosed by current getting produced by this charge is different. If I'm taking charge here, then it is going in this circle and area getting included by this current carrying element will be different. So A is getting different. Then, so we, if we are going to calculate I separately and put the value of area, this whole area, and then find the torque, it will be wrong because I into A is one entity and that will be different for different charge elements we are taking, right? And torque we have to calculate as M cross B. So we need to calculate M for a element and then we need to integrate that or add all those values for all the charges. So how we are going to do that? Let me explain here. So just see, this is the disk. Now in disk, what sort of element we select? Element selection is very important and that you must have studied in your class 11 or in 12 also. I have also dealt with it somewhat. Now, if this is a disk, charge is distributed over area. See, where charge is distributed, area. So your element will also be an area. So we will take a thin strip of disk of thickness dr. Okay. So I have taken this at r distance. I have taken a strip of disk whose thickness is how much? Dr. So why thickness I am taking? Because element I should choose such that it has area. If I am taking element as a ring of radius r, it will only have a length of 2 pi r. But if there is a ring of radius r having thickness dr, then if you're going to open the ring, it will look like this. So it will have area. This is the length 2 pi r and this is the thickness dr. So it has area of length into breadth, that is 2 pi r dr. So its area will be equal to how much? It will be equal to 2 pi r dr. Current value, again, in this area, how much charge is there? How much charge is there in this area? Current, how we will calculate? Current, small current flowing through this loop will be equal to small charge enclosed in this element divided by time period. So how much charge? On whole area, Q charge is distributed. So charge per unit area, Q by pi r square, it will be, okay, where r is the radius of this disk. Now, in this small area, dA, this is charge per unit area. In a small area dA, how much charge will be there? dA into sigma. So for now, I'm going to write dA into sigma. So dQ will be equal to dA into sigma by T. Now, dA value will be equal to 2 pi r dr. So put the value here. 2 pi r dr sigma by T. This is your what? This is your current. Now, this is current. What will be the area of this strip? So now we are going to calculate the magnetic moment. ठीक है? अब आप इसको calculate कर लो. So what will be the value? 2 pi r dr sigma by T is I into area. Area getting enclosed by this loop will be how much? It will be equal to pi r square. Because how we calculate magnetic moment? If there is a loop carrying current I, then magnetic moment is I into pi r square. So area getting enclosed by the loop is taken here as A. That is why pi r square. Done. Okay. Now, M is this. So torque will be torque acting on this small element will be how much? M cross B. Angle between M and B is 90 degrees. So sine 90 is 1. So simply I will do this into P. So here what things are constant? 2 pi is constant. 2 pi r is not constant because it will change depending on where element we are taking. So 2 pi sigma into, again एक और pi है, pi square, and this is your r cube dr, and this divided by t, and b also multiply करेंगे torque निकालने के लिए. So here you write b. This is constant and this is variable. So this was a small torque. Total torque निकालने के लिए we will integrate and r will change from 0 to capital R. ठीक है? Do this calculation, you will get the answer. So tau is equal to how much? 2b pi square sigma by t. r क्यू का इंटीग्रेशन क्या होगा? r4/4. ठीक है? Its value will be how much? r4/4 and this to 0 to r. So r4/4. If you see here, I'm going to simplify it further. 2b into पाई को मैं यहाँ लिखती हूँ, ठीक है, by t. 1 pi is remaining here, so that I'm going to write as sigma into pi r square. 1 r square from here I'm taking, then it will remain as r square by 2. Why I've done this? Sigma into pi r square. Sigma into pi r square is equal to q, that is here 7 millicoulomb. So this is equal to q. So this is q. Now put the value of b, pi, 2. T value, we have already seen that T will be equal to 2 pi by omega. Omega I have already calculated. Put the value, you will get the answer. You don't need to worry now. So answer you will get as this. If you want me to calculate that also I can do. So here let's put the value. If you want me to do that, let's do it. So 2 into B ka value is how much? That is 30 millitesla. 3 into 10 to the power minus 2 into 3.14, ठीक है, into q is again 7 into 10 to the power minus 2. R का square, r is 10 centimeter, so r का square is 10 to the power minus 2 meter square, divided by how much? 2 into t. T is how much? 2 pi by omega, and omega value we have got already how much? 40 pi by 3. So this is 2 pi by omega. Omega value is 40 pi by 3. So right here 40 pi by 3. ठीक है? Now see here, this pi will get cancelled. This is 2 will get cancelled, and this is 3.14. This is 3, so almost cancelled. ठीक है? And 1 2 is remaining here, and this is your how much? 7 into 3. That is equal to how much? 21. 7 into 3. This is 21. So this 2 I cancelled with this. This is 2 again. Done. So this 2 will go out with this 20. Okay. So 7 into 3, 21. 21 into 2, how much you are going to get? Just do it very carefully. See if somewhere we are missing. So if you see here, 1, 2 is coming extra. I've done some mistake. So this is r square by 4. And here, okay, here I have written r square by 2. This 2 will be 4, right? So this 2 will be 4. So if you see here, again, here this 2 was 4. So I'm multiplying it with 2. And this 2, if you are going to do away with, this will become 10. And if you now see carefully, this is 7 into 3. Done. And this 7 into 3 will become 21. Take the power of 10 very carefully everywhere. So you will get it near about 22. 7 into 3 is what? 21. So that is near about equal to 22. Here the power is same for everyone, 10 to the power minus 6. So here also you will get as 10 to the power minus 6. Okay. So this is 22 into 10 to the power minus 6. That is the answer. So now let's move on to this question. So there is a long insulated copper wire that is closely wound as a spiral of n turns. Okay. The spiral has inner radius A, as you can see, spiral and outer radius B, this line XY plane, and current I flows through the wire. So each section has a current, how much current flowing through it? I. through each wire if I take. Done. So if I talk about this turn, it has current I. If I talk about this turn, it has current I. So each coil has current I flowing through it. The jet component of magnetic field at the center of spiral. So what will be magnetic field because of this spiral at the center? Done. See carefully, this spiral will look like what? You can see in the diagram, there is space between two coils. But in reality, there won't be, because in the question it is written, wire is closely wound. Means we are forming a spiral like this. So a spiral is starting from from radius A, and it is going forward like this. I'm not able to form it completely like this. Up to how much radius? Up to B radius. Being no vacant space in between A and B. So basically, there is a depth of, or there is a thickness of wire present here, and that thickness is equal to B minus A. And that B minus A thickness consists of such thin wires carrying current I through itself. And we have to calculate current at the center because of this setup. So if there is a single coil, then if there is a single coil, and if we have to calculate current at the magnetic field at the center, its value will be how much? Mu naught I by 2R, where R is the radius of this coil and I is current field. Okay. And here current is, there is not a single loop. There's so many loops of different radius done. And if they are coming together, they are forming a region having area. है ना? ये region के पास क्या है? एक area है. And through this area, current is flowing. And this area has so many number of coils, and that number is how much? N. N turns of coils are there. So we have to calculate magnetic field. So let's draw it now. Coiling is just starting from, spiral starting from radius A. And in radius A and B, in between these two, there's so many coils of different radius. So what ideally we need to do is we need to select an element. Because of that, we need to calculate magnetic field at the center, and then we will integrate it for the whole area. Okay. Again, elements should be what? Here current is flowing through an area because this spiral has an area. If current is flowing through an area, element will also be such that it will have an area. So I'm going to take a ring of radius R having thickness dr. So this element has a thickness of how much? Dr. Okay. So magnetic field at the center because of this will be equal to how much? Mu naught I by 2R. Now I is what? How much current will flow through this element? This element has a thickness dr. If it has no thickness, then it will have current flowing through it I. Then according to the question. But since it has thickness dr, it will have some number of turns in it. Means it will have some number of coils in it. How many numbers? That we need to see. Now this whole thickness has how many turns? N. So in B minus A thickness of coil, how many turns are there? N turns. In unit thickness, how many turns will be there? N by B minus A. And in dr thickness, how many turns will be there? N by B minus A into dr. Done. So in this element, how many number of turns are there? This many number of turns are there. And each turn has how much current flowing through it? I. So this I value will be how much? Since it has this number of turns, it will have amount of current flowing in it equal to I into this. And I into number of turns. That in formula also we have done, right? If there is N turns of coils of same radius, then magnetic field will be N into mu naught I by 2R. But here, turns are of different radii, so we need to go with integration. Now solve it. Mu naught by 2R, I को क्या लिखोगे आप? Number of turns containing, that is N by B minus A dr into I. Take constant outside. So this is equal to small magnetic field. If you are going to calculate whole magnetic field, we need to integrate. So आप integrate कर दो. R will vary from A to B because the spiral is getting formed from radius A, starting from radius A to the radius B. So magnetic field will be equal to constant को बाहर लो mu naught N by B minus A I dr by R. So integration of dr by r is equal to how much? ln r. And if I go with this only, so इसका value किसके बराबर होगा? ln r. And this is equal to a to b. So ln b minus ln a, that is equal to ln b by a. So this thing is going to get equal to how much? Mu naught ni by, sorry, 2r was here. So 2 we need to write here. 2 b minus a and ln b minus ln a. And this is equal to, this can be written as ln b by a. Okay. So correct answer is mu naught ni divided by 2 b minus a ln b by a. Done. So correct option will be what? A. I hope this is clear. Now we will move on to the next question. So in this question, we can see this is a question from magnetism. And let's read the question first. So there is a particle having charge to mass ratio Q by M equal to K. So Q by M is equal to K as given in the question. And this is projected in a magnetic field B. Here you can see inward magnetic field. And with what speed it is getting projected? Speed of projection is given. And that is your V equal to 2K BD, where 2 is 2 constant, obviously. K is what? Charge to mass ratio. B is magnetic field. And D is what? The width of magnetic field in which this charged particle is getting injected. Okay. Now what? For this situation, mark the incorrect statement. So we have to mark incorrect statement. But before we move on to these statements A, B, C, D, we just need to figure out what will happen if charge is going to enter into magnetic field, how it will move inside, what sort of trajectory it will follow. Then, so we all have studied that when we leave a charged particle, a moving charged particle, in a magnetic field, it experiences force, magnetic force, and its value is given as what? QV cross B. And I have also taught you that if force is like this, here you can see force is perpendicular to velocity because they are cross product, right? F is equal to cross product of V and B. So that is why this. And if force is perpendicular to velocity, the most probable trajectory that we have studied till now is your circle. So definitely under influence of charge particle, under influence of a magnetic field, a moving charge particle will have tendency to go in a circle. Then it may not complete the circle if space is not enough, but it will go in an arc, right? Then now, if it is going in an arc or incomplete circle, in both cases, we need to first find out what will be the center of that circle. And I have told you how to calculate center of circle. How we do that? So just try to find out the direction of force. Done. So here velocity is in this direction. I am calling this direction unit vector in this direction as I cap. I am taking this direction at x-axis. So B is along I cap, and magnetic field, if you see, that is along minus K cap, because that is inward into the field, into the plane. So that is in the direction of minus K cap. Now we have to do V cross V. So I cross minus K. What will be I cross minus K? Again, time and again I used to draw this. So I cross K is what? I cross K is minus J because we are going in anti-clockwise direction. So I cross K will give us what? Minus J. And what will be I cross minus K? It will be plus J. So if this is the magnetic field, inward magnetic field is there in this region, and there is a charge particle coming like this with velocity V, and the moment it will encounter this inward magnetic field, it will experience force in plus J direction, and because of that force, it will go in a circle. If now we move on to circle, we have seen that if force is acting like if that is moving in a uniform circular motion, net force will be directed towards the center. So here also, because of this force, it is going in a circle. So this force will be towards the center, and its direction we have got along J. So center must be somewhere along J axis. That is Y axis. So center will be along this line because force acting at this point is along this. So this is the center of the circle. Now we need to see if this is the center, it can't go completely in circle, because even if it goes in semicircle, it will come out like this, because magnetic field is not present in this region, right? So like this, because center is here, it can't go in a complete circle. Complete circle will mean circle like this. But in this region, there is no magnetic field. So no question of complete circle. But there is a question of this charge particle either coming out on the same side, yani ki coming out here like this, or it's charge particle not coming out, it's crossing the other side like this. So these two cases are possible here. And when these two cases will be possible, just you see here, if it is able to come out on the same side, it will if you, this is center of the circle, if you draw a line like this, so this distance must be equal to radius of the circle. Okay. And how we calculate radius, you all must be aware of. Radius we write as r equal to mv by qb. And here this distance is given, that is equal to d. So radius must be equal to d. So d, m. M by q is given in the question, right? Q by m is given as k. So m by q is 1 by k. Now this is b, and this is your velocity. Velocity is given, that is 2k bd. So आप velocity का value यहाँ पे रख दो. So if we are going to put it, what we are going to get, b will get cancelled, k get cancelled, d can't be equal to 2d. So here definitely radius is equal to 2d, which is greater than that of d. Then it means it won't complete even semicircle, it will come out. So now question has become quite clear. Dekho, this much I am explaining, but if you are aware of this thing, I have also made you solve this question in classes also. But I'm explaining from the scratch so that those of you who have missed, they can understand. Okay, that is why I'm taking this much time. Now it will come out. So our question has now boiled down to fact that this charged particle is not going to come out on the same side, it is going to cross the other side. Now let's look at the options. A, B, C, D I'm talking about. So A talks about particle remains in the magnetic field for a what period of time. So here we need to calculate for what amount of time particle will remain inside this what magnetic field. So let's go for the calculation. Here I have drawn it for you. So radius we have got as what, 2d, and this distance is how much, d. So our charge particle is going along the arc. You can see how much angle this arc is making at the center. Let it call theta. So if I'm saying this point is O, this is P, this is Q. If I talk about triangle OPQ, in this triangle, RQ by RQ, sorry, PQ, that is OPQ now. So this is PQ divided by OQ. This is your height by hypotenuse. This will be equal to how much? Sine theta. And PQ is D, OQ, again B मैंने लिखा है. OQ is equal to how much? 2D, and that is equal to sine theta. So from here we can see theta is pi by 6. So how much angle it is covering? Pi by 6. Now time period. We already know that time taken by charge particle to complete one circle is independent of velocity and all, and its formula is 2 pi m by qb, right? You already know this formula. Now time period means time taken to cover 2 pi angle. Done. So for 2 pi angle, how much time it is taking? Time period t. And for unit angle, it will take how much time? T by 2 pi. So for pi by 6 radian, how much time it is going to take? T by 2 pi into pi by 6. So this is equal to how much? T by 12. So this is equal to how much? T by 12. So how much time, for what amount of time it will stay inside magnetic field? T by 6. Now put the value of T and let's check if A is correct or not. So T is equal to 2 pi m by qb. Okay? And by 12. So m by q, according to our question, if you see question carefully, q by m is equal to how much? Sorry. Q by m is equal to how much? K. ठीक है. So यहाँ पे आप क्या लिखोगे? Q by m is equal to K. So this is equal to how much? 2 pi by, और 2 को कट कर दो. So it will get cut by 6 times. So pi by KB 6 KB something like that. Okay. So what the answer here is given, pi by 6 KB. So this seems correct. We have to pick incorrect statement. So this is correct actually. It travels a distance of pi d by 3 in the magnetic field. So in magnetic field, how much angle it is covering? Pi by 6. So how much it's talking about? It travels a distance of how much? A distance of pi d by 3 in the magnetic field. So distance we have to calculate, okay? And distance is equal to how much? If you're talking about displacement, then this much displacement it is covering, and distance, length of this arc, and length of arc is equal to how much? R into theta, where theta is the angle made by that arc. So radius into theta. And here radius value is how much? This is equal to 2d. Theta is equal to how much? Pi by 6. So this is equal to pi d by 3. So B also seems correct, है ना? B भी pi d by 3 है, ये भी correct है. Angle of deviation from its initial direction is what? Now it's talking about angle of deviation. यानी कि by what angle it has deviated. Done. So initially it was along this line. It was along horizontal. Initially, charged particle was moving in this direction before entering magnetic field, and after coming out from magnetic field, its velocity direction is this. So this is V final direction, this is V initial direction. How much deviation it has suffered, this angle, and this angle will be equal to how much? You just see here, theta is angle between what? Radius and this vertical line. Done. And this line is tangent. So this is perpendicular to the radius. And this line is horizontal. This is perpendicular to vertical line. So if angle between two line is theta, then angle between their perpendiculars will also be theta. So this is going to be pi by 3. So third is also what? C is also pi by 3. C is also correct. Now let's see what is your D. Displacement of particle in the magnetic field is this. You can calculate it, but now since we have sorted all these three, we don't need to waste our time. This is the correct option. यानी कि incorrect statement. Okay. Chalo. So this is all. Now let's move on to this question. In the circuit shown in figure, if both the bulbs B1 and B2 are identical, then what will happen, right? So what the question is here, like there are so many options. Both bulbs have equal brightness. B2 will be brighter than B1. As the frequency is increased, brightness. So we are dealing with the brightness overall in all these four statements. So first let's figure out on what factor this brightness will depend on. Okay. So in first, I'm going to draw the circuit again. So this is capacitor. It will have resistance equal to XC. And there is a bulb. My diagram or my drawing is too weak. So I'm not going to draw the bulb. And this is bulb B1. And here again there is an inductor. Its inductance, or sorry, its reactance will be XL. And there is a bulb B2. Okay? And this hole is connected again to a battery. Now what will happen? Brightness, that is the bulb, when the bulb will consume more power, it will be more bright. Okay, so this bulb also has certain resistance R1 lelo. This bulb also has certain resistance R2. Now power is defined as either in the terms of current or in terms of voltage you can write. So V square V1 square by R1, P1 को मैं लिखूंगी, P2 को मैं लिखूंगी V2 square by R2. Now what is V1 and V2? V1 is the potential drop on B1 and B2 is the potential drop on B2. Okay, so whole battery's potential, suppose at certain time is V. So what will happen? Across this arm, potential drop, total potential drop will be V, and across this arm also total potential drop will be V because they both are in parallel. Done. And within it, what will happen? Some potential will drop here, some here. So if some V dash is dropping here, then V dash plus V2 will be equal to V. Done. And more the potential will drop across bulb, more brighter it will look. Okay, more it will glow. Now both bulbs have equal brightness. We can't say this, right? B2 will be brighter than B1. Again, we can't say like that without knowing what is the resistance of B1, B2, what amount of potential is dropping across these two. Okay, both bulbs are identical. So R1 and R2 are equal. Okay, okay, done, done. So R1 is equal to R2. Though we know R1 is equal to R2, done. इन दोनों के across, इन दोनों का resistance क्या है? Same है. But still, potential drop on this B2 bulb will depend on what is the resistance of XL. If XL is high, it will have more potential dropped on it than that of B2. Then, and if XL is less, more potential will drop on B2. Then, so potential getting dropped on B2 will get guided by XL. Potential getting dropped on B1 will get guided by XC. So we can't say B2 will be brighter than B1. Okay. Now, as the frequency is increased, brightness of B1 will increase. अब आप ध्यान से देखो, XL is equal to how much? Omega L. So if omega increases, that is frequency, XL will increase. ठीक है? And if XL is going to increase, V2 will decrease, right? If XL is going to increase, V2 will what? Decrease. Then this is happening with this inductor wala arm, yani ki with bulb B2. Now, if omega is increasing, XC is equal to how much? XC is equal to 1 by omega C. This is inversely proportional. So if omega increases, what will happen to XC? XC will decrease, and in that case, V1 will increase. And if V1 is increasing, power drop on V1 will increase because V1 square by R it will become. Done. So, because देखो यहाँ पे if here voltage drop is V2, it is V1. So V1 plus VC. ध्यान से देखो अगर नहीं समझ पा रहे हो तो V1 plus VC किसके बराबर होगा? V. V2 plus VL is equal to what? V. Now, if VC is what? If XC is decreasing, VC is decreasing, then V1 will increase. Then, and if VL is increasing, V2 will decrease. That is why I wrote here. And if V2 is decreasing and V1 is increasing, what will happen? Bulb B1 will glow more than that of V2. As the frequencies decrease, the brightness of B1 will increase. This is just the opposite statement of C. So if C is correct, D will be incorrect. So C is the correct option. Okay. I hope it is clear. Now, let's move on to this question. Potential drop across different element is shown for an LCR circuit. Find the EMF of the source. Now, we already know that like if there are only resistors added and if it is given that potential drop on these three resistors are V1, V2, V3, what will be the net, what will be the total potential V of the battery? We will simply add it scalarly, V1 plus V2 plus V3. But if circuit is AC and there is a resistor, there is an inductor, there is a capacitor, and voltage drop is given, we can't add it scalarly. We need to go vectorially, right? And we know how to write those potential things. Okay, so like VC minus VL will go up like this, and this here will it will be VR. Done. So VC minus VL, 100 volt minus 60, that will become your how much? 40 along y-axis, and along x-axis it is how much? 30. Now resultant of 40 and 30 will be how much? 40 का square, 30 का square, vector की तरह add कर दो, 2 into 40 into 30 into what you will say cos 90. So this is going to boil down to, or the final answer that you're going to get is how much? It will be equal to 50, because this will become 1600, this is 900, that is 2500, so that is 50. Okay, so 50 volt. Correct answer will be C. Question was very easy. Okay. Now, this question I made you do so much in class if you have really attended a class of ray optics. Now, let's just draw this thing. This is very easy question. Two plane mirrors are inclined to each other at an angle of 50 degrees. So there are two plane mirrors and they are inclined to each other at what angle? At an angle of 50 degrees. Now, what is happening? There is an incident light, a ray of light that is falling onto one of the mirror. ठीक है, कोई एक mirror पे fall किया. So let it fall on this mirror. Call it mirror 1, call it mirror 2. Okay, and it is falling at an angle theta. Then a ray of light falls onto one of the mirrors at an angle theta, and after reflection becomes parallel to the other, then theta must be equal. So what you can see here, this is incident light. After reflection, it will let me draw in a more clear way. Okay. Then diagrams would not be incorrect because this is a ray optics thing. With diagram, we get answers. That is why we need to be very much careful here. Now it will get reflected by following laws of reflection. It will fall on second mirror, draw normal again on second mirror. And after second mirror, it is said in the question, it becomes parallel to the first mirror. So it will become parallel to first mirror like this. Now let's solve it. Now this is simply a question of geometry. Let's do it now. So it is incident at an angle theta. आप इसको theta ले लो यहाँ पे, ठीक है? This is theta. So this will also become what? Theta. And this whole is 90 degree. This angle will become, this will become equal to 90 minus theta. And if you see here, carefully अगर आप ध्यान से देखो, this line or this final reflected light is parallel to first mirror. And according to correspondence angle, this angle will be equal to this angle. So this is also 50 degree. And if this is 50 degree, this whole is what? 90. This whole is what? 90. So this angle will become how much? 90 minus 50. And 90 minus 50 is 40. So this is 40. This angle will become 40 by laws of reflection. I is equal to R. And if this is 40, this angle is going to become 50. Okay, so this is 50, this is 50, this is 90 minus theta. Sum of all these three angles will be 180. So let's add it. 100 plus 90 minus theta will be equal to 180. Now what will be the value of theta? 190 minus 180, and that is equal to how much? 10 degree. So correct answer is what? 10 degree. I hope it is clear. Now, this is a question from semiconductor that I have taught very much recently. Circuit shown below contains two ideal diodes, each with a forward bias resistance of 50 ohm. So forward bias resistance is how much? It is equal to 50 ohm. And nothing is given in question about reverse bias resistance. So we will consider reverse bias resistance as infinity, as I have taught in new classes. Done. So this is how we move. Done. If nothing is given about forward bias resistance, we consider that as 0. If nothing is given about reverse bias resistance, we consider as that equal to infinity. Okay, so this is done. If the battery is 6 volt, this battery is 6 volt, the current through 100 ohm resistance through this, it is asking. So you just need to check which diode is biased in which way here. This is positive. This is negative, I will say, in terms of potential. So this side is P side, this is N side. Similarly, this is N, this is P. When P is connected to positive, we see that the diode is forward biased. And so D1 is here what? D1 is forward bias, right? Because its P side is connected to positive terminal of the battery. And D2 is reverse bias because its P side or its N side is connected to positive terminal of the battery. So D1 forward bias, D2 reverse bias. If D2 is reverse bias, it will have resistance equal to infinity. There will be break in this arm. Done. So if we are going to redraw the circuit, in place of D1, we will write a resistance of 50 ohm because it's forward bias. Here there is 150 ohm. In place of second arm, we will keep it like this because it has resistance equal to infinity. There will be break in the circuit. Here, this is 100 ohm. This is 6 volt, 100 ohm. So current will flow like this. So this became single loop circuit. No current will go in this arm because this is open circuit, right? This is open arm, not circuit. So how much current you will get in the circuit now? Total voltage 6 volt, total resistance 50 plus 150, 200 plus 100, 300, and that is equal to how much? 2 by 100, that is equal to 0.02 ampere. Okay. So what will be your correct answer? It will be B. I hope again it is clear. Now let's move on to integer type question. Okay, so this was one question, question number 21. I hope you all must have solved it because you people being a students of mathematics, you all must be aware of what geometric series and all. So here we needed to remember that formula. Otherwise, this is a question of electrostat. but only we need to use the basic formula of electrostat. Rest is your mathematics. So if you have solved it, it means you are highly confident or good level confidence you have in your mathematics. And if you couldn't do, please do revision. An infinite number of charge, each having magnitude equal to 2 microcoulomb, are placed along x-axis at 1 meter, 2 meter, 4 meter. Now, let's first imagine it how it is getting placed. So, x-axis you take. Now, call it origin, done. And where the charges are placed at 1 meter, at 2 meter, at 4, the next will be 8, next will be 16, 32, and so on. So on, है ना? So up to infinity it is kept. Such that consecutive charges have opposite signs. So here we will start with positive because nothing is given about the sequence from where we are starting. So we will then by default take first charge to be positive. So यहाँ पे first charge is your plus, here it is negative, here again it is what? Plus, and here it is negative, here plus, negative, plus. All has same magnitude, right? 2 microcoulomb. Now what is said at x equal to 0, electric potential is alpha by beta times electric field intensity. So at origin, we have to calculate electric potential, electric field, and this relation is given, then we have to calculate beta minus a. So let's calculate potential. Potential आप कैसे लिखोगे? Potential का formula क्या होता है? KQ by R. So, uh, okay. I did mistake. No charge is placed at the origin. है ना? Sorry. So let's remove it in first place. यहाँ positive charge होगा, here negative because we will start from 1. Okay. So this is plus, this is minus, this is plus, this is minus, like that. So what is the potential formula? KQ by R. So for this charge, R value is 1. For this charge, R value is 2. For this charge, and so on. Then again, potential is a scalar quantity. We simply need to calculate and put the value. I mean, we simply need to add a scalar. No involvement of direction. Write it here now. KQ by 1 you will write first minus KQ by 2 plus KQ by 4 minus KQ by 8 and so on. Okay? Do one thing, take KQ as common and it will reduce to 1 minus 1 by 2 plus 1 by 4 minus 1 by 8. If you see this carefully, you can see here KQ. This is 1 minus 1 by 2 ka power 1 plus 2 ka power 2 minus 2 ka power 3. So this is a geometric series because in geometric series, this is if this is first, what is that called? If this is first element, then this is your second element and ratio of second by first kitna hoga? 1 by 2 by 1 minus 1 by 2 by 1. So this is equal to minus 1 by 2. Now ratio of this and this will be equal to how much? Minus 1 by 2 ka power q divided by 1 ka 2 ka power 2. So again, this will be equal to minus 1 by 2. So ratio of consecutive terms taken together is what? Same. So this is your geometric series. And this is a geometric series continuing up to infinity. And for infinity, if we have to add such series, what is the formula? Formula is for such series, if I write the formula, it is equal to first term of series, that is A divided by 1 minus ratio. Geometric, what is that called here? I'm forgetting that technical term, but this R is what? Ratio of the consecutive term. Okay, so this is formula if number of element is infinity, and here it is. Okay, so this will be this. Now first term is what? First term value is 1. So here A ka value is 1. R ka value is how much? Minus 1 by 2. So this is minus 1 by 2. So 1 by 1 plus 1 by 2, and that will be equal to 1 plus 1 by 2, so that is equal to 2 by 3. So it will add up to 2 by 3. So potential is equal to how much? KQ into 2 by 3. So 2 KQ by 3. This is potential. Okay. Now, while calculating electric field, we need to be a bit more careful. Why? Because that will involve direction. For positive charge, direction of electric field will be in this sense towards the origin. and for negative charge, direction of electric field will be away from the origin. So what we will do, we will calculate first because of plus q and then because of minus q, and we will subtract it. Okay. So net electric field will be equal to how much? E plus q minus E minus. Okay. So do this thing, write the sequence, what it is. So प्लस क्यू की अगर मैं बात करूं, आई विल राइट के क्यू बाई 1 का स्क्वायर, ठीक है, एंड देन प्लस इज 4, plus charge is at 4 position, so then I will write kq by uh, r का square, that is 4 का square, so that is 2 का power 4, I will say 4 का square means 2 का power 4, again it is at 16, so then I will write kq by 16 means 2 का power 4, उसका square yeah 16 means what, 2 का power 4, so अगर आप इसका square करोगे, how much you are going to get? 256, and that is 2 का power 8, like that it will go on. Okay, and for minus q, if you are going to write माइनस क्यू के लिए अगर आप लिखोगे, डू द सेम थिंग. ओके, so we are moving very slowly, and that is for your convenience, so that you can easily see it. Now minus charge, first minus charge is placed here, so this will be equal to kq by 2 ka square. Okay, and then minus charge is at this, and this is 2 ka power 3, so that is at kq by 2 ka power 3 का स्क्वायर करोगे तो कितना होगा 6, एंड अनदर इज एट 32, 2 का पावर 5, उसका स्क्वायर करोगे तो कितना आएगा 10, सो के क्यू बाई 2 का पावर 10, लाइक दैट. सो प्लस 4 टाइम्स से पावर बढ़ता जा रहा है, and this will also extend up to infinity. Again, these both are a series of infinite terms, right? So what we need to do is we need to add it according to the formula given. Just calculate r for both cases. What will be the value of r for this? इसके लिए r क्या होगा? 1 by 2 का power 4 divided by what you will do 1 by 1, क्योंकि this is 1. Done. So this will be equal to 1 by 2 का power 4. Done. So for first case, if I talk about E plus Q, उसके लिए हमारा कितना वैल्यू होगा? KQ, first term is your 1, and 1 minus R you will do. 1 by R is how much? 2 का power 4. So this is equal to KQ into 1 by this is 15 and this is 16. Okay. So 16 KQ by 15. This is E plus Q. Now E minus Q will be equal to how much? Let's see. So here also, if we are going to divide, or if we are going to calculate R for this case, first term is KQ को अगर common लेंगे, first term will be 1 by 2 to the power 6, second term, and first term is 1 by 2 का power 2. If we are going to divide it, we will get 1 by 2 का power 4. So same R we are getting, right? And also first term here is different. First term is KQ को common ले लो, then first term is 1 by 2 का square, that is 1 by 4, and here first term was 1. Okay, because KQ को common लोगे, 1 by 1 square is 1, so here first term is 1 by 4 and ratio is same, 1 minus 1 by 16 KQ. ठीक है, so what will be the answer? KQ by 4 into 16 by 15. So this is E plus Q, this is E minus Q. What will be E net? E net will be simply take KQ, 16 KQ by 15 को आप common ले लो, 1 minus 1 by 4. This will give you 3 by 4. So 16 KQ by 15 into 3 by 4. And if you're going to solve it, 3 से 5 times में जाएगा, 4 से 4 times में जाएगा. So finally, we are getting 4 KQ by 5. This is the value of electric field. Okay. And what value of potential we got? 2 KQ by 3. So potential is how much? 2 KQ by 3. Okay. So this is how much? 2 KQ by 3. What is electric field? That is equal to 4 KQ by 3. Now come to the question. Electric potential is alpha by beta times electric field. So potential, that is 2 KQ by 3, is equal to alpha by beta times electric field, that is 4 KQ by 3. So if you are going to cancel it out like this, 4, 2 times से चला जाएगा, and here you are going to get what? if you do it carefully, kq by 3. Okay, I have done 4 kq by, not 3 it is 5, right? So this is 5. Now, if you're going to put it, alpha by beta will be equal to 5 by 6. So we can say alpha is equal to 5, beta is equal to 6. So beta minus alpha will be equal to 6 minus 5, that is 1. So correct answer will be what? 1. I hope you have understood. Okay? So correct answer is 1. Now let's move on to the next question. Sorry, by default that is there. Okay. So let's read next question. And this is from what? Instrument section of electricity. So there is a moving coil galvanometer and that is converted into an ammeter reading up to 0.03 ampere by connecting a shunt of resistance 4 ohm across it. Now just let's understand what is the meaning of uh, converted into an ammeter reading up to this. Now ammeter looks like what? In a meter, you will see there is a galvanometer, and this galvanometer is connected to a very small resistance that is called shunt. Let's say this is S. So this galvanometer will also have some resistance. If I talk about maximum capacity of ammeter is I, it means I is what? I is current here of the circuit. If this is the external circuit. Done. So this is I. And this galvanometer has capacity of certain range for taking current. And that maximum current we call as IG. Okay, this thing we have learned already. Now, according to question, what it is said that in first case, I is equal to how much? 0.03. Chalo, case 1 karti hu main. This is I is 0.03 and S value is how much? 4R. IG will be something, it's not given. RG is not given. Now, in second case, what it is said that it is converted into an ammeter reading up to 0.06 ampere when a shunt of resistance R is connected. So in case 2, what is happening? Capacity of ammeter, that is I is 0.06 ampere when shunt resistance connected is equal to how much? R. Done. So we have to see if the maximum current in ampere which can be sent through this galvanometer, that is IG, if no shunt is used, is this. Then find X. Means here students might get confused by when no shunt is used. So its simple meaning is what is the maximum current that this galvanometer can allow through itself, and that is IG it's talking about. Okay. So for first case, let's solve the circuit of ammeter. So this shunt and this RG are in parallel. So potential drop across it will be same. Okay. If here current entering the ammeter is I, here it is I, then it will get divided into two parts. IC, that is maximum current that can pass through galvanometer, will get here, and rest current will go here. So that will be equal to I minus IG. If I calculate potential difference across S, I minus IG into S, and here it will be IG RG. So for first case, IG RG will be equal to how much? It will be equal to I minus IG into how much? 4R. And let's put the value of I actually, because here I is how much? That is given in the question. Done. So I is how much? 0.03. So that is this. In the second case, IGRG will be equal to how much? 0.06 minus IG, because IG will be same in both cases because same ammeter we are using. So RG and IG will be same. And this is this into R. Now this is equation 1, this is equation 2. Divide 1 by 2. Done. So IG by IG RG by IG RG 1 by 1 हो जाएगा. Equal to क्या लिखोगे? 0.03 minus IG into 4R will be equal to 0.06 minus IG into R. If we are going to cut it like this and cross multiply, you will get what? 0.06 minus IG is equal to 4 into 0.03, that is equal to 0.12 minus 4 IG. If you're going to solve it further, minus 4 IG को इधर लेकर आ जाओ, this will become 3 IG and 0.12 minus 0.06, 0.06 and Ig will be equal to how much? It will become 0.02. And here Ig is given as x by 100. So x by 100 is equal to how much? 0.02. That is 2 by 100. So x is equal to how much? 2. So correct answer will be what? 2. Now let's move on to this question. This is basically a question of very much formula based. If you remember the formula, I will solve it. So there is a circular current carrying coil. It has a radius of r. The distance from the center of coil on the axis where magnetic induction, yani ki magnetic field, is 1 by 8 to its value at the center of coil. If this is a circular coil, at its center, along its axis, at any point P, at a distance x, magnetic field B, if it has resistance R and current flowing I, magnetic field E value is mu naught I r square divided by 2, r square plus x square, 3 by 2. And at the center, x will become 0. And at center, magnetic field will reduce to how much? Mu naught I by 2r. Okay? So what is given here? It is 1 by 8, so its value at the center of coil. So if magnetic field at the center of coil is mu naught I by 2r, then at this point P, this is equal to 1 by 8th of this. 1 by 8th of this, 1 by 8th of magnetic field at center is equal to magnetic field at point P. That is mu naught I r square by 2 r square plus x square 3 by 2. Now you just need to solve it. 2 will get cancelled. Mu naught I got cancelled. R square है, इसको R इधर लेकर आ जाओ, R क्यूब हो जाएगा. So 1 by 2r का क्यूब होगा ये, equal to 1 by r square plus x square का 3 by 2. We can see here, this is nothing but 2r का cube equal to r square plus x square 3 by 2. If you are going to bring this 3 this side, it will become 2r is equal to r square plus x square. How much? 3 by 2 into 1 by 3. So this is 1 by 2. अब इस 1 by 2 को इधर ले जाओ. So this will become 4r square and this is equal to r square plus x square. So 3r square equal to x square. X will be equal to root 3r. So value of n will be how much? 3. So this is simple, a formula based question, plain. Now let's come to this question. This is a very love question of ray optics. यहाँ से आता है question. तो चलो इसको ध्यान से करते हैं. There is a slab of thickness 6 centimeter and its refractive index is given how much? 1.5, and that is placed in front of a concave mirror. Okay, so there is a concave mirror like this, and in front of concave mirror there is a slab kept, a glass slab. Okay, now what is happening? If the radius of curvature of mirror, that is R value is 40 centimeter, focus will be 20 centimeter. Okay, and the reflected image coincide with the object. Object is kept such that at the place where object is, at the same place image is getting formed. Now, what is the distance of object from the mirror? So if there were no slab in between, and it is said that object is getting or image is getting formed at the place of object, we will say that object is kept at a distance of what? Radius of curvature. At center of curvature it is kept. That is at 40 centimeter. In that case, 40 centimeter would have been the answer. But here there is a little twist, that is there is a slab kept. Now, what is the effect of keeping slab in front of lens or mirror or any such reflecting surfaces? Kya hoga? So let me tell you, if you have a slab kept in between your object and the mirror or your object and lens, object distance will get shifted towards the mirror, by a distance of 1 minus 1 by mu into t, where mu is refractive index of the slab used and t is the thickness of slab, this thickness. Okay. Why it is getting shifted towards? Let me tell you. Suppose Carlo, this is incident light. It is falling on this surface first. So here it will refract and it will refract towards the normal. So like this. And here also it will refract and here it will refract away from the normal. So, देखो मेरी diagram सही नहीं हुई. That's the issue I face here. ठीक है. I am creative, but okay, in this case, I'm not. Sorry. So here what will happen? It is getting like this, and here it will go on like it will move away from the norm, and then it will fall on the mirror. So light that is falling on the mirror is not directly coming from the object. First, it got bent here like this. So on first surface, after refraction, it seems like light is coming somewhere from here. And after refraction from the second surface, it seems like light is coming somewhere from here. So for mirror, light seems to come from here. Done. So object distance is shifted by distance. And that is equal to 1 minus 1 by mu into t. So just see what is this value of shifting. Put kar do values ko 1 minus 1 by mu, that is 1.5. So this is this into thickness, that is 6. So this is equal to 5 by 15 into 6. So that is equal to how much? 2 centimeter. So by 2 centimeters, my object is getting shifted. Done. Now what will happen? This is the case. Okay. There is a slab. Object should not be kept at center of curvature. It must be placed somewhat beyond center of curvature such that after shifting, it is coming at center of curvature. So how much shifting is happening? 2 centimeters. So object must be kept 2 centimeters beyond center of curvature. Then only to mirror, it will seem like object is at center of curvature. And then image will, जैसे अगर ये center of curvature है, then light will simply retrace the path like this. So image will get formed like this. So what should be the object distance? This distance is how much? 40 centimeter, 2 centimeters beyond 42 centimeter. So object distance is 42 centimeter. Now, x is the object distance, that is 42. 50 minus 42 is how much? 8 centimeters. So correct answer will be what? 8. Now, this is the question that I really love. Why? Because just by looking at the diagram, you can see somewhat it is feeling like things are not in sequence. Okay. But in electricity, I have taught you horizontal line of symmetry and vertical line of symmetry. And also, I have told you if you are confused about things, which things is in parallel, which thing in series, and you feel like you can somewhat bring in the concept of what? That symmetry, you should consider writing all these potential points on the shape. Which potential point? What I'm talking about, I will explain. So 6 registers are arranged along the edge of a pyramid as shown in the figure. The value of resistance are mentioned with the resistance in the figure. Find the value of N if the effective resistance between AB is this. So effective resistance we are calculating along what? A and B. So along A and B, you will connect a battery. This is what I do basically if I have to calculate R equivalent across any 2 points. And this is the ideal way of solving or calculating R equivalent. Okay. So do this. Now, when you will do this, you will realize which is in series, which is in parallel. But you see here, if current is coming like this, here it current will get divided into this portion, this portion, this portion. So series parallel wala concept काफी clearly दिख नहीं रहा है. So do one thing. There are 4 points here, A, B, C, D. So across A and B, I have to calculate R equivalent. So I will take 2 dots. A and B, I will write like this. Done. And C and D, somewhere I will keep in the space like this. This is what I used to do when I get confused about which one is series, which one in parallel. And when I see most of the registers have same resistance value. And there happens to be a case of symmetry, maybe. So that may be case I'm going to explore now. So between A and B, there is a resistor, and this resistor value is how much? It is equal to 2 ohm. Okay. Now, just let me do one thing. I just want it to be more clear. So done. And now across A and C, between A and C, there is one resistor that is of how much? 1 ohm, right? This is, so between A and C, one resistor of 1 ohm, I have kept it. Now another is C and B. So between C and B, there is again one resistor that is of 1 ohm. Now A and D. So here is A and here is D. Between A and D also, a resistance of 1 ohm. And D and B. So D is here and B is here. Along D and B also there is one resistor. This C and D के लिए देखो है क्या? C and D. Yes, resistance of 1 ohm. So this is C and D. So 1 ohm. Now you just see here along A and B I have to calculate equivalent resistance. So I will connect battery across A and B the way I did here. Only thing is I have redrawn the diagram. And what is the benefit of this? I have told you how to apply horizontal symmetry. The horizontal line of symmetry is which line? Line joining the points along which you have to calculate R equivalent. So this is line of horizontal line of symmetry if along this line actually symmetry exists. And it exists. It seems like if this is a mirror, then you can see that uh, right side of the mirror and left side of the mirror has same thing, because this 1 ohm also you can take it 0.5 ohm this side and 0.5 ohm this side, that we can do, right? So if this is horizontal line of symmetry, middle line will be the vertical line of symmetry. So this is vertical. And why I'm interested more in vertical line of symmetry, because for vertical line of symmetry there are more tricks, and we have studied that whatever points lies on vertical point of symmetry has same potential. So potential of C and potential of D are same. And if C and D have same potential, no current will flow through this arm. So this arm we need to remove from the circuit. So our circuit will get reduced to what? आप इसको A ले लो, B ले लो. Now this is 1, this is 1, this has got removed, this was here 2, and this is what? This is what? This is 1, again this is 2. Did you understand? Like this is a vertical line of symmetry. How? Because if you treat this vertical line as a mirror, you can see this is 1, this is 1. So this is mirror image of this is mirror image of this. And what about this 2 ohm? We can again divide 1 ohm here, 1 ohm here. So this 1 ohm is mirror image of this 1. So there is a vertical symmetry then. So whatever points lies on vertical symmetry, they will be at same potential. So circuit got reduced like this. Now battery is. Now it's easy. 1, 1, NC reach 1, 1, 2. This is 2, 1, 1, 2. So 2, 2, 2. All in parallel. What will be the answer? 3 by 2. So like they're in parallel, right? 1 by R equivalent. 1 by 2 plus 1 by 2 plus 1 by 2. 3 by 2. So R equivalent 2 by 3. Answer is 2 by 3. So this is 2 by N ohm. 2 by 3. So N is equal to how much? 3. Correct answer 3. Okay. So this was all. I hope I have covered all the questions you were having doubt in. Again, what portion I have left, the portion that I didn't teach it. And why I left, because I felt like only few chapters we are left with. And I felt like it's better not to explain as of now, because in coming days, I will be explaining those concepts. So nothing to worry about. You all people enjoy, go through solution, please solve all the questions that you were not able to solve, then learn things, learn concepts that you were missing on. Okay. And I forgot what I was to say. Yes. And for every test, please stay more prepared. Go prepared. Just don't go otherwise. Just don't go because you have to go. Go because you want to go. Okay. That is what I want to say. Everyone, all the best for your coming test and for your coming everything. Bye bye. Take care.